Okay, let's do some Calc 3. And these are the first two questions of this review. So we'll see what happens. And yes, this review, as you guys can see, this is part 1. There will be multiple parts of this view, so we'll cover everything in Calc 3. But we're going to start with arc length. Okay, so we know the formula for arc length is, let's just say L is equal to this integral from B to A, R prime of t dt. Or you could also write it as the integral from B to A of what? The square root 1 plus, and it could be f prime of x squared, or you could see it as dy dx or just y prime, but it's just the derivative of whatever function they give you squared, then dx. That's the same thing. So as you can see, we're going to have to use both those formulas for these two problems. Let's do the first one in green. Okay, so we're going to use this formula, right? For number 1. We have to find f prime of x, so why don't we just try to find f prime of x first? So f prime of x is d dx of what? Ln secant x. Well, we know that how to take derivatives in natural logs. So the top part we do the derivative, so we go d dx of secant x, and then we just have secant x. Okay, the derivative of secant is what? I believe it is tan x secant x. Secant x. Okay, and if I'm wrong, well, we can check. Let me just pull. Okay, so here it is, right here. As you guys can see, the derivative of secant x is secant x tangent x. And this f prime of x in this case is just 1. So, yes, I got the correct derivative. Hooray. By the way, that's in a y or a v, that's an x. Make it look a little bit more like x. You can see the secants can go away. So we just get tangent. Okay, so now our integral is, for the first one, let me take my headset off. It is L is equal from B to A. Well, not really B to A anymore. We don't have to worry about B to A. We should worry about pi over 4 to 0. And then we put the square root, and then we have 1 plus tangent x squared dx. Okay. Well, look at that. What is that? What do you guys think that is? That's a trig identity, right? 1 plus tangent x is equal to secant x. Okay. So we can go from from pi over 4 to 0, and it's going to be secant squared x, right? 1 plus tangent squared x is equal to secant squared x. Okay. It's a famous trig identity. And then we can see that this reduces down just to the integral of pi over 4 to 0 secant x dx. And then this integral, what I honestly just remember this one because it's a hard integral. Okay, so it's ln of secant x plus tangent x from pi over 4 to 0. Okay, again, I just remember the integral. I'll pull it up real quick for you guys. Let's go down. Secant integrals are hard, so I recommend just remember them. I mean, it's kind of worth it. Look, secant u plus tan u. Yeah, there you go. So this is what we got. But let's actually get our answer here. So L is equal to ln secant pi over 4 plus tangent pi over 4. So secant pi over 4 is the same thing as 1 over cosine pi over 4 plus tangent is going to be sine pi over 4 cosine pi over 4. And then we got minus ln of 1 over cosine of 0 plus sine of 0 cosine of 0. And if you know those things by heart, like if you know what tangent is, tangent pi over 4 by heart, it's 1, by the way. If you know that stuff by heart, you could just run through it faster. But I'm doing this for people that don't. So we get ln, okay, cosine pi over 4, what is that going to be? So cosine pi over 4 is square root 2 divided by 2. So in this case, since it's 1 over it, it's going to be 2 square root 2. Right. And then sine pi over 4 plus cosine pi over 4. Sine at pi over 4 and cosine at pi over 4 is the same thing, so the same thing divided by the same thing is 1. And then we get minus ln. Okay, now we have 1 over cosine 0. Cosine of 0 is 1. Plus sine of 0 is 0. Now ln of 1 is what? ln of 1 is 0 itself. So we just get ln 2 square root 2 plus 1. That is your arc length for the first part. Okay, for the second one, we're going to do it in blue. So let's do it in blue. And we'll see that, let's just first find the, okay, let's just write what r is. R is equal to x, y, z. Then we know that x, y, and z is equal to what? T sine t, t cosine t, and, okay, so it's, z is just 0, so we don't have to worry about that. Sometimes you'll have a z if you're doing 3 dimensions, but we're only doing 2 dimensions, which is nice for us. And we know that t is from 0 to 1. Okay, well, if we want r prime of t, what is that? That's going to become, so t sine t, we got to take that derivative, and we got to take t cosine t. So we take those two derivatives, so we'll get, it's product rule here, so we'll get sine t plus t cosine t. And then comma, now we got to do the next one. We'll get something kind of similar here, so it's going to be cosine t, but then it's going to be, so it's going to be plus, but there's going to be a negative in here, right? Negative t sine t and 0. Again, we don't even need to write the z part because it's 0, but we could write it. It doesn't actually hurt you to do it. All it does is waste your time, so actually it does hurt you. So if it's only 2 dimensions, just write 2 dimensions. Well, we need to find the norm of r prime of t. Okay, so that means sine t plus t cosine t squared plus what? Cosine t minus sine t. Nope, 1 second. Don't forget your other t in there. T sine t squared. Square rooted, that's how you take the norm of something. Or in other words, a absolute value, right? We just want to find the length of this vector. That's what we're going to do here. So you'd realize that sine t, cosine t becomes sine t plus, now real quick, I'm going to pause here and go in black and just follow this out by hand so it doesn't get messy all under 1 square root. So sine t, 1 second, mess that up again, plus t cosine t. And then squared, what does that equal to? So it's going to be sine squared t plus t squared cosine squared t plus, well, these guys will also be times each other, right? So then we'll have 2t sine t cosine t. Okay. The next one, what do we got for this one? We got cosine t minus t sine t squared. Okay, it's going to be kind of similar. We got cosine squared t plus what? And then we'll see a negative t sine t times a negative t sine t. It's a positive t squared sine squared t. Then we'll get, so we'll have a negative t sine t times a cosine t. And we'll have 2 of those situations pop up, right? So what we'll see is we'll get negative 2t sine t cosine t. And of course, we are adding these guys, right, like it says to do. So what do we see that happens? We see that these guys can cancel. And then we see that we have a sine squared plus a cosine squared. What does that mean? Well, that means that's 1. And then we have a plus a t squared, sine squared, cosine squared t. Sorry, 1 second, let me make this a little bit cleaner. I'll just write it out. I won't skip a step when he goes. Cosine t, sine squared t plus, then now I'll factor out the t squared. We got sine squared t plus cosine squared t. Right, and what does all that equal to? but this is not loading. There's a t, cosine square t here. Okay. So this is 1, and then this is going to be 1 as well. It's the same thing. For some reason the computer's not loading it. So it's 1 plus t squared. I'm going to wait for a second for it to load. Okay, I'm back. I had to help unload groceries. So what we get is 1 plus t squared. That's everything in here when you fill it out. A lot of work. Okay. Let's go back to blue now. So we know that our integral, our length here, is going to be from what? 1 to 0. 1 plus t squared dt. Okay, let's finish up this problem. Okay, so square root. What does this look like? Well, I'll give you a hint. What does a squared plus b squared look like? Right? Doesn't that look kind of similar? So then if that's true, then we have what? That's what we have. I mean, so in other words, we have 1 plus t squared here, and then 1 and t. And let's check if this makes sense, right? So if we have t squared, then we have plus 1 squared, and that is equal to 1 plus t squared square root squared. And yes, that checks out, so this does work. Okay. What that means, oh, by the way, there should be a theta here. So what this means is, well, we can use this information. 1 second. Okay, hopefully the mic isn't picking everything up downstairs, but that's what we got, right? So we can use this information, and then if we see that we have a theta there, then we can really use it more specifically. 1 second, Jim. Okay, hopefully we can get back to this. Okay, so we see that we have t squared plus 1, and we square root that, like, all this makes sense, right? So we can do a trig substitution here. So if we see that we have a t here, what do you think we can do? And if we see that we have a 1 here, well, what do you think we can do? Well, we can say that, let's just write cosine theta, right? Or let's just write tan theta. Well, what is tan theta? Tan theta, it's the same thing as what it always is, right? It's opposite over adjacent, right? And the opposite in this case is t over 1. Okay, what does that mean? Well, let's write this out, you know, like a little bit nicer, so we can solve for t. Well, actually, we don't really need to because it's already there. But let's see what happens if we square t. If we square t, then we get tangent squared theta. Okay. And we have a t squared here. So then we have 1 plus tangent squared theta. Look at that. So if t equals tan theta, then we know that dt is equal to the d theta of tan theta, which is what? Okay, so then that's going to be the derivative of tangent theta, which is just secant squared theta d theta. And I'm writing this in differential form. That's why it looks like that. Okay, but here we go. See, that's everything we need to do this trig sub. So we're going to get this. The integral, we'll get 1 plus tangent squared theta, right? Because t squared is the same thing as tangent squared theta. And then dt is secant squared theta d theta. And then you're like, okay, well, what's the bounds? Okay, well then think about this, right? So we're originally in t, and t goes from 0 to 1, and now we're going to be in theta. So if t is equal to tan theta, then put a 0 into this, right? So, okay, if t is 0, then what is tan theta? What is tan theta, right? 0. If t is 1, then theta has to be pi over 4, right? And that's just trigonometry. If you're confused with this, check it out. Just use the inverse. That's all I'm doing. Okay. So now I can put this back as pi over 4 to 0. Okay. And what do you guys think this is? This is 1. Look, oh my god, look at that. We had that earlier. So this is going to be secant. It's going to go all the way down to secant. So we're going to have secant theta, secant squared theta, d theta, and pi over 4 to 0. So this is our new integral. And look at that. Well, what is this one going to become? Okay, secant cubed, right? Now, we can ask the question, should we do some sort of substitution. Now, before we do that, I want you to think about what we can do. We can do substitution, we can do integration by parts. There's a lot of things. Do we use a trig identity? There's a lot of things, but I need to make more space. Okay, guys, I lied. You can't think about how to do this integral. I will have a video specifically on how to solve this integral because I thought it's actually, it took me a lot longer than I thought it was going to. So I'm just going to give you guys the answer. This would be the answer, and then, yes, you would just plug it in. Since this is a Calc 3 video, I don't think it's necessary that I go over this integral, but in my Calc 2 playlist, I will go over this integral. So if you are confused on how to get to this answer, I will 100% have a video up on it on my channel, and I'll link it in this video.